Hi everyone, this is Dr. V.S. Nishok from EC Department, SNS College of Technology. Here we are going to see the topic Adder and Subtractor circuits using operational amplifiers. So this is the outline of the topics that we are going to see in this video. So here we are starting with the introduction to operational amplifier. So operational amplifier is providing a better output for the weak electrical signals with high gain. So high gain differential amplifier with key characteristics like high input impedance and low output impedance, which are all mainly needed for providing a better result. So and infinite gain. Why we are designing these adder and subtractor circuits using operational amplifiers? So the main reasons are the high accuracy due to virtual ground concept and can handle multiple input easily, immune to loading effects, and configurable for both inverting and non-inverting modes. So here virtual ground represents the concept of if the voltage given to the any terminal is equal to 0, the voltage given to the opposite terminal also will be input terminal also will be equal to 0. So that represents the virtual ground concept. So this will makes the calculation of the output in a better manner, and so that is why we are using this summing amplifier, differential amplifier circuits with the help of the operational amplifier. So coming to the summing amplifier, which is named here as a adder using operational amplifier, here we are connecting two inputs, various voltage signal to the inverting terminal of the operational amplifier, and the non-inverting terminal is grounded with a feedback R2. So with this combination, we are coming for the addition purpose. So op amp is used to design a circuit whose output is the sum of the several input signals. So in this diagram we have seen 2, so it may be n number of input signals we can give, and we can add the voltages. So if the input resistors are equal, so whatever resistors connected with the input voltage, so that is R1A, R1B, so that is represented here. So if the input resistors are equal in value, then the summed output voltage is V out, so that is represented as V out, which is equal to minus V1 plus V2 plus V3. So this is the case for when the resistors are equal. So if the resistors connected with the input path is unequal, so then the output is represented as minus RF into V1 divided by R1 plus V2 divided by R2 plus V3 divided by R3. So based on the resistor values, we need to choose any one of this case shown here in this slide for the addition operation. So similarly, coming to the subtraction operation, so there is a slight change here. So there we are connecting all the input voltages to the single terminal, that is inverting terminal. So here, since it is a differential, we are finding the difference value. So the two voltages are connected to the two different input terminals of the operational amplifier. So if you see the V1 input, that is connected to the non-inverting terminal along with the resistor R2, and V2 is connected to the inverting terminal with the resistor R1. Subtractor is used to produce an output signal, which is the difference between the two input voltages V1 and V2, allow one signal to the subtracted from another. So whatever the higher one will subtract the remaining value and produces the output. So here also the similar to the adder circuit, input resistors are equal. If the input resistors are equal, the V out will be equal. Similarly, if the input resistance are unequal, so if the resistors that connected in the input path are unequal, then the output should be measured with the equation V0 equal to R2 by R1 into V2 minus V1. So this is the case here. So coming to the applications, so while with the help of the operational amplifier, so we have designed the adder and subtractor circuits, and it is widely used in analog computation, audio mixers, instrumentation amplifiers, D2A converters, and signal conditioning. So these are the wide variety of application. Why we are going for the operational amplifier for designing such mathematical circuits. So the advantages of using such circuits are linear operation, scalable for multiple inputs, and limitations like matched resistors, limited bandwidth. So these are the main limitations of this adder and subtractor circuits. So that's all about the topic adder and subtractor. So in this topic we have seen about the introduction to the operational amplifier and why we are designing these circuits, summing amplifier and differential amplifier circuits using the operational amplifier. So what are the applications, and here we are going to see about the assessment. So what does an operational amplifier primarily do? Amplifier amplifies the signal. Why the operational amplifier preferred over any other circuits? This provide isolation and high accuracy due to virtual ground. So whatever we have seen in the previous slides, so that is given here. So and a subtractor circuit is also known as a differential amplifier, and the summing circuit is known as the adder circuit. Thank you for joining this video. We can see in the next video.